This is about completing the square. So if you have a quadratic expression, that is an expression that includes x to the power 2, and you want it written as a complete square, that means something x plus something to the power 2, then there's a method for that. Now, provided the coefficient for x squared is 1, the first thing you do is you look at the coefficient of x and you divide it by 2. So you take half of the x. So this is, half of the coefficient of x. So this 6 you would divide by 2, and that would be the number you put there. So that's divided by 2. Then after, and notice that this positive sign is the same as this positive sign. So whatever you have here, you divide by 2, keeping its sign. Then you subtract that same number squared. So I'm subtracting 3 squared. So it's always a negative sign. And then finally, whatever number you had there, you leave that the way it was. So x plus 3 squared minus 3 squared plus 1. This is minus 9 plus 1. That'll give you minus 8. So this is the complete square version of this. Here we have the complete square, and this is an extra number being subtracted. So that's my first example. Next example, very similar. We take the negative 8 and we divide that by 2. So minus 8 divided by 2 will give me negative 4. So that's this, negative 4. You keep the same sign. So let me just clarify that I'm dividing by 2. And then this same number, I subtract that number squared. So that's the same number squared, and this is always negative. This is always negative. And then finally, this plus 3 is unchanged there. So minus 16 plus 3 gives me minus 13. So this is the complete square version of that, along with that. My final example here, we've got x squared minus 10x. So I'm going to do the exact same thing. I'm going to take the minus 10. I'm going to subtract half of that, or I'm going to divide minus 10 divided by 2 to give me minus 5. And then I will then take the 5 and square it, and I'll always have a negative sign here. And then the negative 6 is as it was. So this is the complete square version of that. Now, the advantage of writing my quadratic in this form, or one of the advantages, is it allows you, so once it's in this form, for these examples, a was equal to 1. But once we have these two numbers here, that allows me to find the location of the turning point, or the vertex, because remember, this is a quadratic. Each of these is a quadratic, in these cases at least, that opens upwards. So quadratics will have a turning point, a minimum point or a maximum point, and we call that point the vertex. And the coordinates of the vertex we can find from these two numbers, b and c. So the coordinates of the vertex are minus b and c. So that means that the first number here, the number that's added to x, we change the sign from positive to negative, and this number that's added, we keep it the way it is. So that's how we find the vertex. So we can go back and find the vertex for each of our examples. So for our first example, the vertex will be at -3, -8. For our second example, the vertex will be at 4, -13. So notice how I change the sign from negative to positive for the x, but for the y, I keep the sign as it is. And finally here, the vertex will be 5, -31. So that's how we would complete the square when we have a quadratic expression with a coefficient of 1 for the x squared.